Students, here we are going to study center of mass, that is COM, conservation of linear momentum, impulse and collision. First of all, we understand center of mass. We have seen the motion of particles in the kinematics and we treat them as a single point. When we see the collision of big objects, then we don't treat them as a point, but then also we use the center of mass as a point, center of mass. It helps us here in performing all such type of problems while we deal with the big objects. Either it is collision or we have to find the linear momentum of them, or in any kind of rotational motion. You might have seen the motion of a ball. If the motion of the ball is in a straight line, then we treat it as a point object. But if you throw a bat, then see how finally it moves. If you throw a bat, then it will move by rotating in this way in the 2D plane, and finally you will see that this is a rotational motion. But if you want to describe its motion, then this, its center of mass, it will be in a parabolic path. So the center of mass will follow a parabolic path. So we need the center of mass to describe the motion of an object. And we see how we find center of mass and center of gravity, and what is the difference between center of mass and center of gravity. So we have used the term center of gravity many a times in the previous chapters. And what is center of gravity? And what is center of mass? So come, let us see what is center of gravity, and then we compare it with the center of mass, and then we will understand the method to find them. So come, let us see what is center of gravity. If we see a car, then this is a very big system, and this system, on its different part, the gravity will be in somewhat this manner. These are the forces. We can represent these forces as the vectors. For now, I am not taking all the parts. I have drawn the forces for few parts in this way. As many masses as I can see, I am including it here. We have almost included all the masses of the car. Now these all forces have a vector sum. Vector sum is for more than two vectors. If we see these two forces, then these are two parallel forces. There is a difference in their point of action. I have previously told you about force that point of action is very important here. And there is a difference in the point of action. We are seeing they are parallel. They are not collinear, and the point of action are not common for them. So there will be one resultant force whose point of action will be between these two point of actions. Suppose their point of actions are F1 and F2, then the resultant will be F. Definitely we can write it in the vector form as F1 plus F2 force. So here the direction of F will be in the direction of F1 and F2 obviously, but the point of action will be, that will be on the line joining the point of actions of F1 and F2, somewhere in between, and this ratio we can find. And if you want to find out this ratio, then we will find it in the chapter statics which we study. There you will be getting it. But here our purpose is that we have to understand that the sum of all the vectors will give out to be a single vector, and the sum of all these vectors will be a particular vector which can be called equivalent to the mg. M is the mass of the car and g is the gravity. So this vector passes through and starts through the center of gravity. So this is the point, that is the center of gravity. Center of gravity means the point at which gravitational force appears to act. Center of gravity is that point where gravitational force appears to act on the car. This is the sum of all these vectors. If you sum up all these vectors, if you do their vector sum, then that vector will be equal to this mg vector, and whose point of action also you can find out using this algebra or this formula. Although it is not important for us to find it out here, we have to understand that center of gravity is a vector which will pass through the center of mass of the body. If the object is small, then. If the object is too large, then. If the object is too large, like there is a hill, a very big mountain, and mountains are there obviously, If we find the center of gravity of this mountains separately and then we find the center of gravity of all these mountains, so it is not necessary that it coincides with the center of mass. Center of mass doesn't depend upon gravitational force, but the center of gravity is the vector sum of all the gravitational forces for a very big object. We can find the center of gravity in this way. But here we have to keep one thing in mind, that for all the vectors the direction will not be parallel because the earth is a spherical object, and in this vectors if the mountain is very big then the direction will be different for them, and along with at every place the value of gravity can also be different, that is the acceleration due to gravity may be different from point to point, that is mountain to mountain, it can be different. That's why center of gravity should coincide with center of mass. This is not necessary in case of big objects, very big objects, especially for very big objects. For small objects, the center of gravity is the center of mass. The definition for the center of mass which we study is clear. It is the point where whole the mass of the object is supposed to be concentrated. That means there only our whole of the gravity is acting. So for small objects, if we call center of gravity in the place of center of mass, or we call center of mass in the place of center of gravity, then there is no problem with it, not at all. So come let us see how we find the center of mass. Come let us see center of mass of two particle system. If there are two particles in a system, then how center of mass is being found? We have taken the size of the objects very big. The size of the particle is very small actually. Then too we will be treating them as the particles, and their centers will be the center for these particles for us. And now we will be finding the center of mass of this system of these two particles. Suppose the distance between them is r, and center of mass is somewhere here, and this distance is suppose r1, and this distance is suppose r2. So we have to find center of mass here. What is the property of the center of mass? Before finding the center of mass, we should write one property that it is a very good property, but we cannot use it here. That is sum of moments of masses about center of mass is 0. Here you cannot find the moments because you have not learned it. Moments means if from center of mass you multiply the distance from the masses, then the sum of the moments will be 0. And moments, if you keep it in the gravitational field, then about the center of mass, the moments will be the torque. If you want to find out center of gravity, then about the center of gravity, the sum of the moments is 0. So this will be true also for the center of mass of small objects. So if you apply gravitational forces m1g and m2g and find their moments, then they around the center of mass are 0. And the second thing, the distance of the center of mass. If we talk about the distance of center of mass from one object, suppose the distance from the center of mass is d, which is inversely proportional to the mass. So here our r1 will be, that will be inversely proportional to m1, and the r2 will be, it will be inversely proportional to m2. In fact, we can say m1 r1 will be m2 r2. If we treat here as a constant, then m1 r1 will be equal to m2 r2. And with the definition of moments on, also we write the same equation, m1g r1, but this you can write only if you have studied class 12th. Here we can write one more small equation, r, that is r1 plus r2. Total distance r is r1 plus r2. So if you want to find out r1 from here, and if you substitute the value of r2 in terms of r1 here, m r1 is equals to m2, the value of r2 we will write it from here, r minus r1. On simplifying, we will be getting the value of r1 m2r upon m1 plus m2. And in the same way, if you find the value of r2, then it will be m1r upon m1 plus m2. Equation is very good. You see here what will be the value of r1. the value of R1 will be M2R upon M1 plus M2. If you increase the M2, you increase the M2 mass.